The Ben Heck Show is brought to you by Element 14, the electronic design community and online store built for engineers and hobbyists alike. Join now and browse the store at element14.com.
What the?
I don't think it's gonna hold!
This is taking forever. There's LARPers everywhere out there. I know Minecraft is popular and all, and the LARPing is cool, but the thing that I like about it is that you can create logic gates within the Minecraft game. People have even built whole computers using the methods. What I'd like to do in today's episode is make our own little logic blocks, basically real world examples of those logic gate cubes that you can plug together and create circuits like in the game. Let's get started.
Amazing builds, exclusive mods, cutting-edge ideas, electronics, engineering, and more. Every week on Element 14's The Ben Heck Show.
I'm going to assume you're all familiar with Minecraft. I'm just going to draw a few gates to show you what we're talking about. So we take 3 blocks, we put torches here and here, put redstone here, then we put switches on the side. Okay, so this is going to be an AND gate. And the result is this redstone over here. It's kind of hard to see this light block since it's daylight in the game, so I'll just bring the redstone out. Okay, so the redstone's active. All right, so, okay. So that's an, oh, I'm sorry, that's a NAND actually. So if both of these are down, and in Minecraft down means on, or we'll call it 1. If both of these are 1, then it sends a negative output, or a NAND. To make this an AND gate, we actually put a torch here. Oh no, I destroyed the block. Oh, I gotta do that. So a torch on the side going to some redstone, that actually acts as an inverter. So now our, oh, a creeper. Now our AND gate works as it should. So if this and this, oh wait, that's not working. Oh, I forgot the redstone. Okay, there we go. So the default state of blocks is you can stick a torch in and it'll light, and these torches are lighting this redstone here. And a torch, then this torch is being activated by the redstone, which means it's being inverted. So a torch on the side of a block basically acts like an inverter. So we'll probably want to make a special block just to represent a torch on the side being an inverter. So as an AND gate, if this and this, then the redstone lights up. So that's definitely one of the gates we want to be able to make. All right, oh no. Oh, he blew up on me. Let's think about how we're going to make some real world Minecraft block-like logic toys. I downloaded this sheet online. It shows all of the logic gates you can make in Minecraft, so that was very helpful. And I've narrowed them down to a few selections. So we want to make NOT gate, OR gate, and AND gate. Those are very basic gates. We could also make a NAND or a NOR, inverted AND or OR, which would make them universal gates. You can make any gate you wanted out of them, but that's probably getting ahead of ourselves. So as we saw in the demo, there's usually a block with a switch on it. So that'll be our input mechanism. And we should be able to plug torches into that because the torches seem to invert what the block is doing. Obviously redstone is a big deal in Minecraft. So we're gonna wanna make a lot of little flat redstone blocks. I mean, we can't make redstone dust, but we can make a thin block that acts as redstone. And we want to have a 2-way, basically just goes that way, and then a 4-way, like 1 input and 3 outputs. Putting a torch on the side of a block has a different function than it does putting it on top, because a torch on the side of the block will affect the redstone next to it. So we'll probably need to make kind of a side block. Like this would be a block that would plug into a switch block with a torch and redstone on it and 3 different outputs. And this would be inverted, so if the switch is off, the torch is on, and if the switch is on, the torch is off, and the redstone's on. That's how you make a basic inverter in Minecraft. Finally, we want some sort of result you know, the result of our logic circuit. So we'll just make a bright light box, or perhaps you have a motor on it. This is, you know, what'll happen at the end of our chain. Okay, let's build some blocks. The first step will be to see just how small we can make them based off the largest component, which will probably be the coin cell battery. Let's go take some measurements. Let's take a look at our parts. Here is a 3-volt lithium coin cell, and this was the smallest holder that I could find. I also found these larger black holders. They hold the same size cell, but it takes up a lot more space. So I think I'm going to use this as my baseline. So I'm going to get its measurements. Obviously this is going to be the largest measurement. It's 1 1/8 inches on the head. So much of the metric system. So what I'm going to do is I'm going to take the longest measurement, and then I'm going to add a good amount of slop, because it's not just the size of the piece, but you need spacing around it. Then you need a thick wall, and then also however many screw holes you need. So in this case, I think we're probably going to be looking at 1 1/4 for the XY on the case. So here I have 123D Design, which is the free program from Autodesk, and I should just get Inventor, but I just haven't gotten around to it yet. So on our drawing here, we have some mounting holes, and then these openings here are for the pass-through points. So I'm going to put this at an angle. The base floor, I'm going to make 0.05. Okay. This part, it's going to be a little thicker, so the PCB can rest on it. All right. Next, I'm going to get our openings. Even though they're openings, they still have to have some thickness to them. All right. And finally, the walls. Now, each one of these blocks is going to snap together, so this just represents the bottom of it. Okay. So that is what our base cube is going to look like. All of the cubes, no matter what they do, will have this same base because they'll all have the same circuit board. Let's 3D print this and see what it looks like. Here is our test base. I made it red, like redstone, and we want a circuit board to fit in here, and then in these gaps we'll have headers so they can interconnect. So I'm going to use CADSoft Eagle to design a circuit board. All right, so I'm going to use something called a multifunction gate. It's a smaller integrated circuit that can be configured into several different types of gates. We don't have a lot of room in this box, so we need the smallest, circuitry possible. If you look at this here on the screen, this basically represents how it's going to work. Each connector has 3 pins. It's going to have voltage, ground, and then a signal. The signal is going to be the logic. We have the signal coming in here at the bottom, and then it goes to signal in. And signal in will go to a header so we can wire it to our multi-function logic circuit in different configurations. Basically, we can kind of solder it the way we want it to. I know it sounds kind of counterproductive to manually solder something that you've made a circuit board for, but it's not as dumb as it sounds. We have a decoupling cap here. This is our light. So if you want your piece of redstone to run the light, we run the signal into the circuit. We just basically have it do if high, then high, and it will light up and then pass the signal to the other output pins. The board view of this, all right, here we go. We take this off of our drawing. We have our 2 holes here that line up with our 3D print. We're using all surface mount. There's an LED here. You don't have to use the LED, but you can. And then I have a few bridge points. Like if you look at this right here, these 3 here are the signal coming in, and these are the 3 gate inputs for the multifunction gate, and the output is here. So if you want it to work like an AND gate or an OR gate, basically how I bridge these connections will change the configuration of this circuit board. That way I can just make one circuit board and use it for multiple different cube types. All right, so I'm going to go to element14.com and check out their manufacturing partners. One of them is Pentalogix, which is a quick turn PCB service here in America. We can order these boards and have them in about 5 days. I printed out on paper my PCB design, and then I cut it out. As I've always mentioned, if you print something and it fits within a page, it will always print actual scale. So I just want to make sure that this is the right size before I spend money on an online order. And it fits. All right. Again, it's an easy step to do that can save you money. Paper is cheap. Now it's time for a tech timeout. For today's tech timeout, let's talk about the multiple logic gate circuit that we're using to create our logic blocks. It has several gates combined that you can do many things with. Specifically, there's 3 inverters on each one of the inputs. There's 3 inputs. Then there's an AND gate, a NAND gate, and an OR gate. And this truth table shows you that when you put the inputs in like this, you will get this output. For instance, with our redstone, we tie the 2 outer pins low and the center one is connected to the signal so that it represents the output. You basically get the same thing you put into it. But we could also create AND gates, NOR gates, XORs, or quite a few other things just by how we wire up those 3 connections that I made available. So we can do an inverter or an AND gate or whatever we want. So we can use that same circuit for multiple types of cubes and we can configure it just by how we set the jumper settings. I got the PCBs back from Pentalogics. It only took about 5 days, so that was pretty convenient. So the idea with these is we can configure them in many different ways. Here's one that I've already done, and I'm going to copy it on camera so you can see the parts that went into it. So we have a surface mount LED that will fit inside of our redstone case. And these are the multifunction logic gates. It's a SOT6 chip. It basically has power, ground, 3 inputs and 1 output. So we can configure it multiple different ways. And then here is where we put our headers. Now the best way to assemble these is actually next to each other, like this, so that we know everything's aligned and the headers will fit. I mean, you can have some slop, but yeah, the closer the better. These parts are a little small. A hot air gun might be a better way to do it, but you know, again, if you don't have one, you can still do it with an iron. The side of that, you know, is exposed. So I'm just gonna heat that up. There we go. Oh, that moved a little bit. See how the solder pulls it in place? I'm still waiting for a few more parts on this. I don't have the right resistor rating, which is supposed to be 39 ohms. However, if I take 275 ohm resistors and put them in parallel, that'll get us in the ballpark. Actually pretty close. Because when you put resistors in parallel, you get twice the current carrying capacity and half the resistance. So 275s is, you know, like what, 38, 37? These are the multi-purpose logic gates. They're kind of small, but that's good because it means they fit in the cube. This is a capacitor, just going to put a capacitor on each one of these for decoupling, just a good idea to have. Keep the power supply stable. These aren't quite the right size capacitors, but they'll work. These are 1205s and the pad I use is 0805, which refers to the size of the component. But that's close enough. It's gonna be covered up, no one's gonna see it, ha ha ha. All right, I'm gonna add the headers now. So at the bottom is the input header and the other 3 are output headers. We're gonna make different types of blocks. Some blocks will have 3 outputs, some will only have 1. But, you know, the circuit board is making it so we have choice. And it's a lot faster than wiring these by hand. A lot faster. It's always something you should think about when you're building things. Like, yeah, circuit boards can be expensive, but how much is your time worth? There are certain jumpers on this board, such as these here and this one down here, which basically allows you to set what the PCB is going to do. So these are just going to be pass-through lights. The on or off state comes into the input, and lights or doesn't light the LED. But by leaving this disconnected and connecting, for instance, this pin to this pin, we can turn all these inputs to torch inputs. Like if you stick an LED torch into the side of the cube, it caused it to behave in a different way. So again, it was just trying to put as much functionality into a single circuit board as we could, you know, to save money. I'm putting these cubes next to each other and then soldering the connector with it in place so it's as straight and level as possible. I'm going to solder the middle one, put it in place, then solder the other two. So all these pins act as a bus. So if you connect all these together, unless you connect them upside down, which hopefully you wouldn't do, as long as you connect them together, the bus is always the same. So if we applied a signal to one of these, all the lights would light up, which I guess we can test. And this will simulate the veins of redstone. Okay, let's do a test. Let's apply power and ground. So the lights have come on because the signal is not actually connected to anything. But if we go low, they'll all turn off, except for this one, which appears to be having trouble. All right, if we go low, they'll all turn off, and of course high turns them on. So right now it's kind of in a tri-state, which is why you actually have to ground it or put it to positive voltage to get a consistent reading off of it. So what'll happen is we'll have a control block down here that you have a switch on with torches, and then these modules will be used to, you know, carry the signal between, you know, separate blocks. The tolerances are pretty tight. See this lip here? These lips actually go between the walls and the PCB, so the PCB isn't centered basically perfectly. This doesn't fit. This one's pretty good. It's not perfect. I guess I could probably readjust it. Some of these are just inline. See how there's just one on each end? So probably what you'd do is you'd have a switch block here, which we'll probably make in the next episode. Then you could come here, you could go at an angle, another angle, and then up to something else. All right, I have most of these enclosed, but I left this one open just so you can see it. Now these are the redstone blocks. They're just gonna pass the signal through along with power and ground. So we apply power, they may or may not turn on, but see how they're kind of flashing? That's because this is the input pin that goes into the multi-logic gate, and it's floating, it's neither high nor low. So if we go low, it turns them off, except for that one, which appears to have problems. Guess we'll have to look into that. That turns them off, and this turns them on. So in our switch block, we'll have some more logic that actually dictates what the rest of this does. So it could be inverted as well. So, you know, if these are all on, they could end up at another block, which if these are on, that block is off, and vice versa. So we're sending power and ground through them all, but we're also sending a logic level that can be changed. We could even make some of these that invert, you know, that turn it from low to high, but these are meant just to pass it through. But we still have to stuff the circuit, otherwise it doesn't work. But those logic gates are only a few cents. This one's being a little weird. Maybe it was just loose. It was at the end of the chain. I mean, normally you wouldn't need this much redstone, but... Now I have plenty of redstone parts to interconnect all of my Minecraft logic blocks. That's all the time we have for today. In our next episode, we're going to make the other logic blocks that we need to complete the equation, specifically torch pieces, switch blocks, and light columns. We'll see you then. I think those people are still LARPing outside. Looks like Starburst. All right, I'm recording Camtasia, your favorite Disney movie. Oh, so I'm two different ages? I am in a quantum state? You're gonna get married to like the Duke of, I don't know, some important aristocrat, and it's like your wedding day and you're like, that's when you look in the mirror and you have freckles. That's exactly like Frozen. And of course, the one that I do on camera doesn't go together well. It's still not working.
Yeah, does it look appropriate?
You look awesome. Can you see me?
Well, we should just turn the Ben Heck Show into a talk show. Like today in the Ben Heck Show, quantum mechanics. Also, Jessica Simpson weight gain.
Hi, I'm David Finch. I'm with Element 14, and I have here today the new Raspberry Pi Model B Plus. And I just wanted to take it out of the box here and share with you some of the new features that it offers.
The Ben Heck Show is brought to you by Element 14, the electronic design community and online store built for engineers and hobbyists alike. Join now and browse the store at element14.com.